Hello everyone, welcome to your next chapter and section. In this one, we're going to learn all about natural language processing. So we're going to do an introduction into this thing called NLP. Essentially, NLP is just an integration of linguistics with computer code and computer science. So we can analyze large sums of text in automated ways and do all these calculations that a linguist could do by hand, but instead we do it automatically using clever programming techniques. So natural language processing is really useful if you're doing things like trying to understand the sentiment of phrases. So chatbots are really hot right now. Data scientists can do a lot with chatbots. You can do sentiment analysis on Twitter response, on tweets. So you can tell whether some politician is being received well after they said something on the news or something, based on how people are responding to certain tweets. You can do all kinds of different stuff that is really useful as a data scientist that integrates with a completely different area of science and language. So with that, guys, how we can think about connecting this is that we just scraped some information from a website the other day where we had it was song lyrics. So maybe you can start to think of ways that you can integrate your web scraping techniques with your natural language processing by the end of this lecture, or by the end of this chapter at the very least. So with that in mind, guys, what you're going to learn today is a couple of basic concepts and terminology in linguistics and natural language processing. I'm going to introduce you to this package called NLTK, which is Natural Language Toolkit. That's what it stands for, as well as some of the functions involved in NLTK. And then we're going to go through some very basic natural language functions that you can use. Remember how I said before that Python is a really good language for doing natural language processing with, and it's because of how easy it is to slice strings. So getting your feet wet with Python and NLP is probably one of the best integrations of code with a specialized area that is out there right now. Python is great for dealing with language stuff. So I hope you guys are excited, because I surely am to teach you some of this. So let's go through some definitions. First, we're going to talk about some linguistic definitions, what a lemma and a stem is. So a lemma is basically, if you go into the dictionary and you find the definition of a word, how the word is presented at the beginning of as the first part of the entry of the dictionary. That's what we call the lemma. It's kind of almost like the core word before it is modified by adjectives or tense or verb or something like that. Okay. The stem of a word. This should maybe be familiar to some of you, is basically the root word. What the word is without any modifiers on it that tell you more information about what the word is doing. Okay? Lastly, we're going to talk about this concept in natural language processing called tokenization. So what this is basically how we count and organize all of the words into into our calculations when we do NLP stuff. So when we do natural language processing, one of the first things that we do is we get all of the entire corpus, the body of text that we're using, and counting every word that exists in it, and placing little labels and markers for what the words actually are in the sentence. Is it a noun? Is it a verb, adjective, and so on and so forth. So that process is often called tokenization. Okay. So with that, guys, first thing we're going to do is I'm going to talk more about natural language processing and parts of speech. We're going to forego a syntax section where we look at code and just jump into some very simple stuff so you can see how these two things are integrating in Python. So first, what we're going to look at is something on a website here. Here we are. And on this website, what we're looking at is the parts of speech for a sentence. You see here, the sentence is, what is the width of a football field, ? Okay? And what you're seeing are all of these different labels for what each word is. So this is like a noun, a singular noun. This is also a singular noun. That's what NN means. And it's also saying things like this is a noun modifier. and this is, the subject and the root. So all of this stuff that you see here is something that a linguist can analyze in any piece of text. They can break it down into this basic parts of speech grammar, essentially. And what you can do with this even further is start to assign things to each of these values. For instance, like maybe the word hate or love is positive or negative in terms of its intention or sentiment. So you could effectively maybe start weighing the sentiment of each of these words as happy or sad. Another linguistic trick that you could possibly do with a sentence like this is to try and infer the intent or what the topic is about from all of this. You can also start to calculate how unique is this sentence, or what is the vocabulary level or skill of this writer given a little bit more text. These are all things that you can do with natural language processing and Python. And I'm actually going to show you how we build this with a sentence in basically one line of code once we hop into that Jupyter notebook. The next thing I wanted to show you here, guys, is so you saw in the past tab that we had like WP, NN, IN. That's what all of these short forms are representing. So IN was a preposition or subordinating conjunction. A DT is a determiner. So you can read through all of these different definitions and you'll see what these are as part of English grammar, okay? And so what we can do with our Python code is automatically have it tell us what each of these things is within a sentence, phrase, or paragraph, or even book, okay? So guys, that's the syntax I wanted to talk to you about today. I wanted to talk to you about the syntax of linguistics and what are some of the things that we should be considering when we start to think of ways we want to analyze language. We are actually going to analyze language in subsequent sections, but it's really important for you to understand how and where we're taking this approach and what we can do to get there. Okay, everyone, here we are in our Jupyter notebook. You'll notice that I have this. First off, make sure that when you go into Anaconda, you're installing Natural Language Toolkit, NLTK, and you want to import that package first. The first thing we're going to want to run is this nltk.download function, and I'll show you why. Let me run this. It's going to take a little bit to boot up, but give it a second, and it's going to toss up a window for you. You don't need to download all of this stuff, but what I would recommend downloading is what this does is it boots up a window for a bunch of important packages or useful packages in NLTK that are not downloaded automatically because they're fairly large sometimes. The only thing I think you should need to download is all the corpora and then all the packages available. So these two here, okay? So all we're really going to be looking for is we're going to download a body of text that we can play with, and then the additional functions and packages, excuse me, that exist in Python, or at least this exists in NLTK. So it might take you a little bit to download these. So make sure to pause this video and get them all downloaded before you start. I'll just give you a quick couple seconds. Okay, hopefully you guys have now downloaded if you haven't already. Let us now go into some of this code and see what's going on here. So first off, it just outputs some information from the NLTK download function. We're going to remove that now, just comment it out. And these first three lines are importing functions that we're going to use. So we're going to tokenize a phrase today. We're going to get the parts of speech like we just saw above, or just saw previously. We're going to lemmatize words, and we're going to stem words. That's what all this is doing here. That's what these three things we've imported and have ready to go in our Python, Python code ready to run. The next thing we do is we're going to create two objects, which are a word lemmatizer and a word stemmer. So that way we're going to pass a couple of functions within WordNet lemmatizer and within Porter's stem to see if we can make words lemmatized or stemmed. So here, these two functions here are just printing the lemmatizer function, and we're saying we want to give it the word dancing, and it's a verb, and we want to turn that into a lemma. And the next one here is taking the same word and trying to stem it, and we'll see what happens. Okay, it's just loading some packages. There you go. So it took dancing and turned the verb form into dance. and then it took dancing again and took it down to the stem, which is just that there, because a stem of this is without any kind of, tensing or modification. So if you added danced, ed, it would say that you danced previously. If you said dancing, it's saying you're dancing now or in the future. So that's what a stem is, and that's what a lemma is with these two examples. In our next example, what I'm going to show you is how to tokenize a sentence in Python. So we have this phrase, today I started learning NLP, and then we're going to use the NLTK's word tokenize function to see what happens when we tokenize this. What it ended up doing was it turned our entire sentence into a list, where each word is an element in the list. Now what we can do with this, there's another way to do this. The word tokenize has a couple other functions that are going on that will, clean up your tokenization process a little bit more, but we can do this with knowledge that we already have as well. So if I just go tokens2, we could go phrase.split. If you look at what the split function does in Python, you'll realize that it will take a string and then turn that string into a series of elements in a list based on whatever characters you want it to split on. So if we split on spaces here, this is going to create a list with today, I started, and so on and so forth. Let's even print that and see what comes out. Tokens2. Print, and actually turns out to be exactly the same. Now the word tokenize stuff has a couple other functions going on, but essentially that's all it's doing. It's splitting a string into a list of words. Now imagine you had a language that doesn't use spacing as some form of delineation between words. You wouldn't be able to use this technique for other languages, or some languages at least. Most languages do have spaces, but it's an important thing to keep in mind, and linguists know this very well. So the next thing we're going to do is, let me just bring back that old code. Apologize, I must have erased it. Oh no, we had it right there. Next thing we're going to do is look at the parts of speech of these tokens, this list of words, and see how easy it is for Python to render this. Look at that. So we get a list, and each element in the list is a tuple, where the first element of the tuple is the word, and the second element of the tuple is the part of speech. So we don't even need, we can do this really easily and automated using these awesome natural language processing packages. That's all about where I want to end off, guys. I wanted to just introduce you into NLTK to show you how powerful it could possibly be. I wanted to show you some of the basics of linguistics. So if some of this stuff is really catching to you, you think it's really cool and awesome, you should look more into linguistics and natural language processing. We taught you how to install the de facto package for natural language processing in Python, which is called NLTK, and ran a couple of functions showing you how easy parts of speech are with that. Okay guys, with that, thank you very much, and I'll see you next section.